Good afternoon. This is Ms. Billerbeck, and we're going to go over the last section of Unit 4, Factorization by Grouping Terms. So when we have 4 terms, that gives us an idea. If they're all a little different and we can't combine them, and we have 4 terms that we might want to try factorization by grouping. So there's a couple things we could do. Okay, so the first thing we could do is just put parentheses around these 2 and say, I'm going to take out like terms for this and like terms for this and see what is left over. So when we do that, let's prime factorize. So we have 2 times 3 times a times x plus 2 times 5 times a times y. Oh, so when we do that, we see we have 2's and a's that we can take out. So let's look at this one. We have 3 times b times x plus 5 times b times y. Well, that one we don't have so many things that are the same, but we could take a b out, and that's about it. So let's take the a's out of this one. So we have 2a, and that leaves us 3x, and over here we have 5y. Okay, so plus, and then we take the b out of this one, b, and we have 3x plus 5y. That's interesting. This is the same thing as this, but it looks too complicated, way too complicated. So what we're going to do is we're going to say, I can't look at those. We're going to call these z. Okay, so now we're going to say we can't deal with it. It's z. So z equals 3x plus 5y. And let's rewrite this. So now we have 2az plus bz. Oh, look, we have something in common. They have z in common. So we can take z out. So we have z times 2a plus b. Wait a second. We know what z is. We just couldn't look at it. It looked too complicated. So really the z is this. So this actually is 3x plus 5y times 2a plus b. Huh, isn't that interesting? Well, that's very complicated, but this is the answer. Let's try it in a different way. We'll take the same thing and we're going to do it in a different way now. So, okay, our original equation was 6ax plus 10ay plus 3bx plus 5by. Let's make a box. And we're going to put each term into this box. All right, so we know that the area of each one of these boxes is the length times the width. Okay, So what we're going to do is try to figure out, well, what's the length of this? And it happens to be what's in common with this. So we know that this is really written as 2 times 5 times a times y. So they have a 5 and a y in common. So we can write 5y. Okay, so they have a y and a 5 in common. This one is 2 times 3 times a times x. So when we look at what do they have in common, they have a 3 and an x in common. So we're going to write 3x. Then we look at, well, what do these two have in common? They have a 2 and an a. So we're going to write 2a. And then we look at, well, what do these two have in common? And they have a b. So when we put that together, we can add these two as a length and add these two as a width, or a base times a height. So now to get the full area, we can write that that's 2a plus b times 3a plus 5y would give you the total area of this box that we just created. Okay, and if we look at that, this happens to be the same thing as 3x plus 5y times 2a plus b per the commutative law of multiplication. So when we look at that way and this way, look, it's the same answer. See that? Same answer. No difference. So you can do it this way, or you can do it with a box. Okay? So let's try the next one. All right, so first we'll try it by just using grouping symbols. But this is a little scary right here because there's a negative. Okay, so that's where we might run into trouble with the parentheses. So actually, let's try the box for this. Because I think when you have too many negatives, it's too easy to make a mistake. So let's try the box. So we have 18 AZ and negative 30 CZ and negative 15 A and 25 C. Okay, let's break them down. So the prime factorization of 18. So if we have 18 and we prime factorize that, that's 2, 9, 3, 3. Yes, we have already done that one. 2 times 3 times 3 times A times C. Okay, 30 prime factorized. We haven't done that one. So that's 2, and we have 15, then 3, and 5, because 1 plus 5 is 6. 6 is divisible by 3, so it's factorized by 3. And we also have a negative 1. So 2 times 3 times 5 times C times C. Okay, so 15, well, we know that's 3 times 5, so let's take the negative 1, and we have 3 times 5 times A. And this one we have 25 is 5 times 5 times C. Okay, let's start taking out things that are alike. So when we look at, well, what's alike here, we see, well, we have a 5 and a C and a 5 and a C. So let's take a 5C out. And we look at this column and we see we have an A and a 3. A and 3. So we're going to take 3A. Put a little plus sign there. When we look at this, we see we have a 2 and a 3 and an A. Wait, there's no A, but there's a Z. So 2 times 3 is 6 and Z. So we have a 6Z. And here we have, oh, you know what's interesting? Okay, so this is why these negative signs are so rough. When we have a negative here and a negative here, this is tricky. So let's talk about that. So when you have a negative here and a negative here, this is not just 5 times 5. No, no, no. So let's rewrite that. This is -1 times -1 times 5 times 5 times C. Oof. Okay, so we have to remember that when we're using the box. If both of these diagonals are negative, that means this is a negative and a negative. Negative times negative makes a positive, so it was hiding. We didn't see there were 2 negatives there. When that happens, that means they have a -1 in common. And that's not a plus sign, but a minus. That's a big mistake if we forget that that's a negative times a negative. All right, so we have a -1 then in common here. And we also have a 5. So -1 times 5 is -5. So when we add these together, it would factor as 3A minus 5C times 6Z minus 5. And that's how you'd factor. But you might say, wait a second, that was really, really confusing. So let's go back to this method and see. We'll just do this method really quickly. So let's see, let me find an extra board. I've used them all. Okay. So let's see why does this work this way? How confusing is this? So we have 18AZ minus 30CZ. And let's make this plus -15 A plus 25C. All right. So now we're going to use our grouping symbols and try to make some sense out of this. Okay. So now let's find the prime factorized version of these. So we have 2 times 3 times 3 times A times Z minus 2 times 3 times 5 times C times Z plus, and then in here we have -1 times 3 times 5 times A plus, and then just for, should we, I'm thinking, should I go with the negative times a negative here? If I want to take a negative out. Well, let's not. Let's just do it like this because we don't know these things yet. Okay, now let's find our like terms. So for this one, we have a z and a 3, and those are like. So let's pull that 3z out. And we have 3z and 3z. So that leaves 2 times 3 is 6. 6 times a is 6a. Minus, and then we have 2 times 5 is 10. Times 6c is 10c. So here we look at, well, what do they have in common? So we see, well, they have a 5 in common. So we're going to pull the 5 out. Okay, so that leaves us negative 3a plus a 5c. Oh, we missed something, didn't we? Okay, so we also could have taken a 2 out. So let's do that. Okay, so sometimes we miss something when these parentheses and we're factoring by grouping, when this isn't the same as this, that means that we miss something. So 2 times 3 is 6z, which leaves us just 3a, and in here we just have 5c. And look how close those are. They're just missing a minus sign. If I'd taken another negative sign out, then that would have been the same. So let's divide by negative 1 right here. And when I do that, I'm going to multiply by negative 1. So that gives me 6z times 3a minus 5c plus, and negative 1 times 5 is a negative 5. All right, so then when I divide by negative 1, a negative divided by a negative is a positive 3a, and a positive divided by a negative is a negative 5c. Wow, look at that. This is the same as this now. So what we can do is, if we can't deal with this and this, if it's just too much for our eyes, we can say, well, we are going to say, how about y equals 3a minus 5c? And then we rewrite this 6yz, because y is before z in the alphabet, minus 5y. And then we see, oh, they have y in common. We can extract the y, and we have 6z minus 5. Now we can put the y back in because we know what that is. We just didn't want to look at it. It was too complicated. So it was 3a minus 5c times 6z minus 5. Aha. So this, oh my goodness, look at that. After doing all of that, look at that. It's the same thing. So there's 2 ways to do this. You can do it this way, or you can do it this way. But remember, if the diagonals are both negative, this is a negative times a negative in the square. Okay? Right, let's try one more example. And then we are done with Unit 4. Bravo. Okay, so let's try the box method. This time we'll make a little box and try to fit them both on the same page. So we have 7ax and negative 21x and a 12. Oh, we first need to see, is there any like term that we can combine before we do this? Nope, they're all different, every single one. Okay, so 12, and then we have negative 4a. Okay, now we're going to break this into prime factorization. So this is just 7 times a times x, and this is negative 1 times 3 times 7 times x, and this is negative 1 times 2 times 2 times a, and this is, well, we didn't do that. So 12 divided by 2 is 6. Take a 2 out because that's still even as 3. So this is 2 times 2 times 3. So now we can look at, well, what do they have in common? So this one is a negative 1, and that's it, negative 1. Let's look at this. So this column here, they don't have anything in common. That's not good. So if they have nothing in common, that's also a 1, which that doesn't make any sense. So we need to really look at our strategy here. But let's continue. So this one would be 7x. And this one down here is 2 times 2. So that's 4. So we just have to figure out, well, what is this right here? Did we forget something? Maybe what we should have done is rearrange these two. Aha, because we can't figure out what goes here. So let's try this again. Okay, let's put the 12 over here. We'll fix up our box. So we're going to put the 12 here and the 4a right there. Okay, and we write our prime factorization. That was a negative 4a too. So negative, oh wow, what did I say? If you have a negative and a negative here, what happens? What happens here? There's 2 negatives in there. So we have negative 1 times negative 1 times 2 times 2 times 3. And then in here we have negative 1 times 2 times 2 times a. Okay, so now let's see what we can do, if this helps at all with the situation. Okay, so let's go back and figure out, what do these have in common? There's a negative 1 and a 3. So we can write negative 3. And what's like this one? Okay, so we have an A, and that's it. But now we need to go back to this one because we changed this once we realized this diagonal was a negative negative and this was a negative times negative. So we see that they not only have 4 in common, they have a negative 1. So that means that this one should factor as 7x minus 4 times a minus 3. Okay, so let's try that with the parentheses now and see what we get. So we have 7ax minus 21x plus 12 minus 4a. And let's put a parentheses here and a parentheses here. So we have 7 times a times x minus, and then this is 3 times 7 times x, and plus, and then we have 2 times 2 times 3 minus 2 times 2 times a. So we look at what do they have in common? 7x. What do they have in common? 4. So we pull the 7x out of this one, we extract it, and we have a, and what's left is minus 3. Plus, and we pull the 4 out of here, and we have 3 minus a. And we say, oh, I see the problem. We need to divide by -1 and multiply by -1, because that means we're not doing anything to it. So when we do that, we have 7x a minus 3 plus, and then -1 times 4 is a -4, and -1, 3 divided by -1 is -3, and negative a divided by -1 is a plus a. So this is really x. 7x is ax minus 3, and if we just rearrange this, it's a minus 3. So we see they both have an a minus 3, so we end up with the outsides here as 7x minus 4 times a minus 3, which is the same thing we have here. Okay, so there's 2 ways to do this. Isn't that wonderful? Because this is so complicated. And that is the end of Unit 4. Have a wonderful day.